China has quietly crossed another major milestone in unmanned aviation, one that could have far-reaching implications for both civilian air mobility and future military operations. In late December, China successfully flew its largest tilt-rotor unmanned aerial vehicle to date, marking a significant step forward in the country's vertical flight and autonomous aviation capabilities. According to information released by United Aircraft Group and confirmed by Chinese aerospace authorities, the 6-ton class Lanying R6000 completed its maiden flight on December 28th at a dedicated test facility in the Deyang Shifang area of Sichuan province. Officials described the test as a foundational achievement, opening the door to a new category of heavy, long-range unmanned rotorcraft within China's rapidly expanding aerospace ecosystem. The R6000 is not just another drone. It represents a new generation of high-speed, long-range, vertical takeoff unmanned aircraft that blends the advantages of helicopters and fixed-wing platforms into a single system. Developed by United Aircraft Group, a private aerospace company headquartered in Shenzhen, the project highlights how China's private sector is becoming deeply intertwined with the country's broader military-industrial strategy. Although the company promotes the platform for commercial and emergency use roles, its growing cooperation with state research institutions suggests that the line between civilian innovation and military application continues to blur. At its core, the Lanying R6000 is a high-performance tilt-rotor UAV, a configuration that allows it to take off and land vertically like a helicopter while transitioning into forward flight like a conventional airplane. This hybrid design gives it remarkable operational flexibility. With a maximum takeoff weight of approximately 6 tons, the R6000 occupies a class that very few unmanned aircraft in the world have reached. It is capable of carrying up to 12 passengers or an equivalent payload, a figure that immediately places it far beyond traditional medium or tactical drones. Its performance specifications are equally striking. The R6000 is reported to have a top speed of around 550 kilometers per hour, making it one of the fastest unmanned vertical lift aircraft ever flown. Even more significant is its stated operational range of approximately 4,000 kilometers. This combination of speed, range, and vertical lift capability places the platform in a category normally reserved for crewed tilt-rotor aircraft, while removing the risks and limitations associated with onboard pilots. Officially, United Aircraft Group presents the R6000 as a solution for long-range logistics, emergency evacuation, disaster relief, and civilian transport missions. In such roles, the aircraft could deliver cargo or personnel to remote regions, islands, mountainous terrain, or disaster-stricken areas without relying on runways or developed airfields. However, military analysts see far deeper implications embedded in its design. From a defense perspective, the R6000's large internal volume, long endurance, and ability to operate without runways make it an ideal candidate for intelligence, surveillance, and reconnaissance missions over vast distances. It could also support special operations forces, autonomous resupply missions, and rapid insertion or extraction tasks in contested environments. In scenarios involving island chains, disputed maritime regions, or rugged border areas, a platform like the R6000 would offer commanders a level of flexibility that traditional fixed-wing drones or helicopters struggle to match. Technologically, the aircraft is powered by a sophisticated fly-by-wire control system combined with autonomous flight capability. Engineers involved in the program have emphasized its stability during hover, smooth transition between vertical and horizontal flight modes, and reliable performance at higher altitudes. These characteristics are essential for a tilt-rotor platform, where the shift from helicopter-style lift to airplane-style flight represents one of the most complex challenges in aerospace engineering. The R6000 reportedly incorporates advanced sensor fusion, precision navigation systems, and redundant avionics to ensure safe and reliable operation. Additional features such as de-icing systems and collision avoidance protocols further underline its readiness for real-world conditions rather than controlled demonstrations alone. These design choices suggest that the platform is being developed with sustained operations in mind, including use in complex airspace or harsh environmental conditions. This milestone comes amid a broader global surge in unmanned aerial systems development. Over the past 2 decades, drones have evolved from simple reconnaissance tools into multi-role platforms capable of conducting strategic-level missions. Beijing, in particular, has invested heavily in this domain as part of its military modernization drive. From long-range export success stories like the Long and CH series armed drones to more advanced and specialized systems, Beijing has steadily expanded both the depth and breadth of its unmanned aviation portfolio. Stealthy, high-speed platforms like the WZ-8 and advanced combat drones like the GJ-11 are already being integrated into China's long-term force projection and anti-access strategies. What makes the R6000 stand out is its focus on vertical lift combined with long-range autonomy, a capability that remains relatively rare even among the most advanced drone programs worldwide. Tiltrotor UAVs represent a shift in how future air operations may be conducted. Rather than relying heavily on fixed infrastructure like airbases and runways, future missions could increasingly depend on flexible, self-deploying aerial systems capable of operating from confined spaces. This has particular relevance in modern warfare, where fixed bases are highly vulnerable to missile strikes and long-range precision weapons. With the successful maiden flight of the R6000, China joins a very small group of nations that have demonstrated heavy-class tiltrotor unmanned aircraft. In doing so, it narrows the technological gap with well-known U.S. programs such as the Bell V-280 Valor and the V-247 Vigilant, both of which explore similar concepts in crewed and uncrewed vertical lift aviation. While the R6000 is still in testing phase, its size and performance suggest that China is moving rapidly beyond experimental designs toward operationally relevant platforms. Further flight testing, system refinement, and certification are expected to continue through 2026, with export-ready variants potentially appearing before the end of the decade. If successful, the R6000 could appeal not only to domestic users, but also to international customers seeking long-range, vertical-lift unmanned solutions for logistics, surveillance, or emergency response missions. More broadly, the R6000 sends a clear message about the direction of China's aerospace ambitions. Private companies are no longer just followers or subcontractors within the defense ecosystem. They are increasingly driving innovation, experimenting with bold designs, and delivering capabilities that can be rapidly adapted for military use. In a global environment where unmanned systems are reshaping both warfare and civilian air mobility, platforms like the Lanying R6000 highlight how quickly the balance of technological leadership can shift. As the global drone arms race accelerates, heavy tilt-rotor UAVs may become a defining feature of next-generation air operations. With this successful flight, China has demonstrated that it intends to be at the forefront of that transformation. This is Mighty Military, bringing you deep analysis of the technologies, platforms, and strategic shifts shaping the future of air power and modern warfare. Stay tuned and stay informed.